Hello, geometry students. I wanted to work through this review with you on circles, looking at the inscribed and central angles, and then the associated arcs that go with them. And then I want to review our surface area and volume. Okay, so here we start with this information. In the diagram below, angle BCD is 90 degrees. So I'm going to start first by marking that in. This is 90. This is a central angle. So our central angle being 90 degrees means that the intercepted arc is also 90 degrees. Remember, our central angle and intercepted arcs are equal in measure. So here from B to D, this is my first X value because I want to know the measure of arc BD. So if my central angle is 90, my arc is 90 degrees. Okay, so I'm going to come down here and I'm going to type in that 90. Okay, now I am going to use that 90 to find the measure of angle BAD, and that's this angle. This angle is inscribed, so it is going to be half the arc. Okay, so just to recap, the measure of angle BCD equals the measure of arc BD, but the measure of angle BAD equals half the measure of arc BD. Okay, that is so important to remember. If your vertex is on the curve of the circle, we take half the arc. Okay? If my vertex is on the center of the circle, the arc and the angle are equal in measure. So here I am going to take half of 90 to get 45. So this angle here is 45 degrees. Okay? So then I will submit that question when we got those points, and we can move on to question 2. So the measure of arc AB is 63 degrees. So this is 63 degrees, so that goes from here to here. I want to find the measure of theta. Theta is my central angle. Our central angle is equal to the measure of the arc. So if my arc is 63, then theta is 63. So the measure, I'm going to use theta. So theta equals the measure of arc AB. So theta equals 63 degrees. So that's all I need to type in here is 63. Okay, let's submit that and make sure we get our points. There we go, and move on to question 3. Question 3, we want to find the measure of arc AB and then the measure of arc EDC. Remember, when we have the third number, it gives us a starting, a direction to go, and an ending. Okay, so that's arc EDC. For arc AB, we are going to use, again, it looks like I have a 90-degree angle marked in here. So if that's 90, then this is 90. Okay, so I'm going to type my 90 in here, and it's asking for a unit of measure, so that is in degrees. Okay, now you may notice that there is a segment going from point E to point C and passing through the center of my circle. That means this is a diameter, and it is cutting my circle exactly in half. Now our circle all the way around is 360 degrees. Half of that is 180. So total degrees in a circle is 360. A semicircle is half that. So that is 180 degrees. So I'm going to type that in here and then put, oh, it helps if I actually click in the box, right? So 180 and then my units of measure, submit, there's our points. Okay. Next question. All right. Find the measure of arc AB. Now it's a little hard to see on this picture, so let me zoom in a little bit. So you might see I'm going from here all the way around the outside of my angle. This from A, the long way, it's saying we're going to go the long way here. This is our 330 degrees. This is X. X is what gets me the rest of the way to 360. So really for this one, we're going to take our total and subtract what we have used to get what's left. So this is 30 degrees as our solution. Okay, there we go. So let's take a look at question 5. Okay. The measure of arc XY is 73 degrees. Let's find theta. Okay, so this is 73 degrees, right? This is an inscribed angle, so theta is going to be half the measure of our arc. I almost wrote 73. I meant to write arc XY. So theta equals half of 73, which is 36.5 degrees. Okay, and it's okay to have decimals. We do not need to have exact angle measurements. 36.5 degrees looks good. All right. And let's move on to question 6. Okay. I think question 6 and question 8 are exactly the same. So we'll double check that to be sure. But if not, it's the same process. Okay. So we have a radius of 2 centimeters, and I don't think we actually need that information. Okay, so we want to find the measure of arc EB. So you might notice that we know arc GB and we know arc GE or EG. And the only part of our circle that we do not know is arc EB. So I'm going to call that X. Okay, so I know for this one that 155 plus 50 plus X equals 360. That's my total circle all the way around. Okay, so 155 plus 50 is 205. Plus X is 360. So if I subtract 205 from both sides, I get X equals 50. No, that's not right. 155. Sorry, my brain is, I'm really tired. Okay, so 155 degrees. So 155 plus 205 is 360. It's only 9:20 p.m. and I am exhausted. What? Okay, the measure of angle GFB. This angle, this one here, is a central angle. So it is going to equal the measure of its arc. So if this is 50, this is 50. Okay. Angle GEB is my inscribed angle. Okay. That is going to be half the arc. So it will be half of 50. So I am going to take half of 50 to get 25. Okay. There we go. Let's submit that. Fantastic. Next question, number 7. All right. So again, we have an inscribed angle. We are going to use that to find the arc, then to find our central angle, and then to find the measure of the rest of the circle. Okay, so first things first, if this is an inscribed angle, the measure of angle PRQ equals half the measure of arc PQ. That is my X to start. And I know angle PRQ is 62 degrees. So I am going to take half of X to get 62. And you might remember that to undo multiplying by a fraction, we multiply by the reciprocal on both sides. And that gives us 124 for my X. So 124. Here it is in degrees. Okay. Now, my central angle equals my inscribed or my intercepted arc. So if this is 124 degrees, this central angle is 124 degrees. These will be the same value. And again, it is in degrees. All right. This arc is 124. Arc PRQ is the rest of the circle. All right, so my 124 is from here to here. I want to know what PRQ is. Okay, so for that one, we are going to take our 360 total and subtract out the 124. And that gets me 236 degrees. If I am thinking clearly, I am fading very fast. Okay, there we go. All right, brain fog included. Here we go. And question 8 is the same as question 6. So test your recall, see what you can do on that. And that will be the end of that task. Okay. And then I have another one for us here. This one is using surface area and volume in addition to the circles. So there are some more circle questions in there. I'll let you try. I can make another video on those tomorrow. All right, some of them are the same. So let's talk surface area and volume. So remember, lateral surface area is the part around the middle. It's without the bases. So if you're talking about our formula, remember surface area is twice the base area plus the perimeter times the height. This part here, this is our 2 times the base area. This part is the perimeter times the height. Okay, and then our total surface area is the sum of the first two boxes. Our volume equals the base area times the height. Okay, let's see if I can move this over. Hide that. Okay, so let's take a look at our base. So remember, I like to list out my variables and then just kind of sketch. So it looks like my base is the 12 by 10. Okay, so here's 10, here's 12. So I know my area of that is, I'm going to put that on the inside. No, because I have to do the perimeter also. All right, so the area of that is 12 times 10, or 120. And I've got two of those. So I'm going to do 2 times 120 to get 240. Okay. My lateral surface area, I need my perimeter of the base. So it's going to be that 12 and 10. So I've got 2 of my 10s and 2 of my 12s. That's 24, 34, 44. Okay, so my perimeter is 44. My perpendicular height is the 20.3. So this down here, my perimeter is 44. My perpendicular height is 20.3. So I'm going to multiply those together using my calculator. Okay. My calculator is 44 times 20.3 to get 893.2 equals 893.2. And this one was 240. So let's type this in, 893.2. And then my total surface area, I'm going to add those together. So what do we get? 1133.2. And I'm trying to do this mentally, and I really shouldn't because I'm super tired. Yes, 11,133.2. Now, my volume is just going to be the product of all my dimensions. Okay, so we have 12 times 10 times 20.3. So let's multiply those all together. 12 times 10 times 20.3 to get 2,436. 2,436. Submit. There we go. And everything shifted up. But pause, rewind if you need to. Okay. All right, surface area and volume of a prism. How about surface area and volume of a cylinder? Okay, so again, same concept. Our surface area is still twice the base area plus the perimeter times the height. But we have a circle, so we're going to change our area, our base area, to r squared times pi, and our perimeter to twice the radius times pi. And our volume, volume is that r squared pi times that perpendicular height. Okay, so that's the difference between a cylinder and prism, is that for our cylinder, our base is always a circle. Okay. And in a prism, it can be a square, it can be a rectangle, it can be a triangle, and a hexagon, and a pentagon. But we're going to keep it simple this year, okay? All right. So my area of the two bases together, that's my 2 times r squared pi. My lateral surface area, again, is the perimeter times the height. That is my twice the radius times pi times the height. My total surface area is the sum of those two. And then my volume is that r squared times pi times the perpendicular height. Okay, so let's do our calculations. Base area equals 2 times my radius squared times pi. My radius is 6. Okay, and the 16 is my height. So 2 times 6 squared times pi equals 36. So 2 times 36 pi equals 72 pi. Now it does say we can round to 2 decimal places. All right, so I'm just going to leave this 72 pi though, and then I'll round at the end. 72 pi. All right. My lateral surface area is the, we'll call that LSA, is 2 times the radius times pi times our height. So 2 times 6 times pi times 16. So 12 pi times 16. 12 times 16 is 192. All right, 192 pi. Okay, these are like terms, so I'm going to do my 192 plus 72 to get 264 pi. 264 pi, and I don't know if it's going to like me keeping these in pi form or not, but it doesn't matter. All right, r squared pi times h. So when I do this one, that gives me my radius squared times pi times 16. So 36 pi times 16, and that is 36 times 16, 576 pi. Okay, 576 pi. All right. Let's see if it likes those answers or not. Oh, it took it. Fantastic. Pi form for the win. Then I don't have to worry about rounding. I can keep it simple. And I think that is it. There we go. All right. Have a great night, and I will see you tomorrow.